First is the optic nerve. Like most major nerves, it's myelinated. What does that mean? It means it's got a lot of fatty layers wrapped around it. The Schwann cells wrap around the nerves and lay layers of fat on them to insulate them so they can transmit impulses better. It's got a lot of fat here and it all has to come off. So I need somebody to hold things for me while I wrench on them. Anybody want to hold things? No gloves? Come on.
Here, I've got gloves on.
All right. Come on over here, Lainey. All right. Well, I guess we can come in from that side. All right. So just go ahead and hold this side, and I'm going to start cutting things off. If this takes too much time, we'll bypass. I'm going to try to get through that glove and get preservative all over you anyway.
Okay.
So, as you know, there's a hardened layer that kind of keeps the shape of the eyeball, the sclera. And there's an outer layer called the fibrous layer and an inner layer, which is called the vascular layer. And so some parts of the eyeball have no circulation. They just have to get nutrients and get rid of waste by diffusion, like the cornea, the clear part in the front. Obviously, you can't have blood vessels blocking your vision. So eye is obviously a very critical part of survival, so much so that we see the development of a vertebrate-style eye with lenses and irises and everything, all the way down to some of the cnidarians, the jellyfish. Some advanced jellyfish have a very vertebrate-like eye. It's going to be the more mobile creatures, of course, because they've got to see ahead of them before they move in. All right, I think we got most of what we need here. So it says, I believe, who's my reader? So it says you can cut all the muscle off, so you have all kinds of, I think there's 6 major muscles here that orient the eye. And we're not going to pay attention to that today. All right, so I'm going to try the scissors thing before I try the scalpel thing. And so it says you're supposed to cut across, I don't know if they call it a frontal plane here, but basically cutting just around the equator of the eye. And anybody cringing because they feel like their eye is stinging? Dr. Casper tells a horrendous story about her eye, which I'm not going to repeat, but you can ask her. All right, so it's just squirted. That means we're into the liquid part. So ahead of the lens, up here behind the clear cornea, which has now become translucent because the preservative affects it, there's a fluid called the aqueous humor, and then behind is one called vitreous humor, which, as you might think, means it's very viscous. And is gel-like. So I'm going to see how well we can do here. It's not squirted into my eye. I noticed I didn't get my goggles on. This is a place to squirt your eye very nicely. Whoops, and I'm going around in a spiral. All right, so we got a couple of things here. This is your vitreous humor, the very gel-like stuff, and I'm going to pull that out. But keep it, and here you can see the lens, which again has become pretty opaque because the preservative messes it up, right? You all see that. Here, of course, you're looking at the back side of the iris, and there's a couple of structures here which I actually ripped off. There's some ciliary muscles that go from the outer rim of the lens out to the sclera of the eyeball, the stiff kind of orb here. And what do you suppose that does? Why are there muscles running from the edge of the lens out to the eyeball?
Changes the shape of the lens.
Right. As they contract, they flatten the lens, and that would be what you need for distant vision. And then right in here, this is the iris and the pupil, the hole there, right? And here at the edge of the iris is a sphincter, a circular muscle, which squeezes the lens and makes it thicker for up-close vision because it has to bend the light rays. We call that accommodation, right? So here you can see this is all very darkened, and that's probably for a purpose because you don't want a lot of light bouncing back and forth in the eye and confusing the focus. So back here, the choroid layer, very dark. Who's my reader? Help me, tell me what I need to tell you.
Carefully remove the lens and vitreous
Vitreous humor, yeah.
humor if attached, and observe that the ciliary body merges anteriorly
Yeah, well, we
into another
wrecked it.
component of the vascular tunic, the iris.
Yeah, we ripped it. Okay. So that is something you're not needing to know.
Well, the
All
iris
right.
surrounds an opening, the pupil.
Right here,
In the
okay.
cower sheep eye, the pupil is more irregular in shape than in the human eye. The pupil allows light to pass through the vascular tunic to the lens.
Okay, so the vascular tunic is this inner layer of the sclera here, this white layer, and then the fibrous tunic, right, is the outer layer. All right, go ahead.
The iris is a sphincter muscle.
Right,
What is its function?
okay, so it makes the lens more orb-shaped, makes it thicker, changes the focal length of the eye. All right, what's next?
Turn your attention to the posterior hemisphere of the eye.
All right,
If
here.
dissected as described, this hemisphere should hold the vitreous humor,
Okay, which we pulled out, yeah.
which holds the retina in place.
Okay, so this is the retina, it's just membranous looking, but of course this is a lot of nerve tissue. You have cones and rods that are light receptors in the retina. And then right in the middle, you'll see that it comes loose pretty easily, but there's a certain place in here where it adheres. If I can find it, I'm ripping everything up. Right in here is where all those nerve fibers go into the optical nerve, which comes out here, optic nerve. All right, so this kind of tan stuff, that's all retina. All right, what else?
Using forceps, carefully remove the vitreous humor and identify the pale, delicate retina. The sensory layer, the third tunic of the eye. The retina contains microscopic rods and cones. What is the function of the retina?
All right, so light reception, right? Here, the something lucidum, tapetum lucidum, which isn't in every eye, but especially in nocturnal creatures, they need to magnify the light as much as they can. So if you see something, you're shine a flashlight and it's really bright green or really bright red, that's the tapetum lucidum reflecting light back through the retina to get a second shot at receiving the photoreceptors, the light receptors. All right, so they basically amplify their ability to see in the dark. All right, what else is there?
The retina lies on the inside surface of the pigmented choroid layer.
Yeah, that's the dark stuff in here, right?
It absorbs extraneous light rays passing through the retina, gently pushing the retina aside. Hold on.
Okay, so I think that's most of what you need to know, isn't it? Anything else? All right. Back to, yeah, you don't have a lot of time. Whatever you are doing, if you